Good day to you and welcome to this Motec webinar. My name is Dwayne Mitchell. I work in the Motec R&D Centre in Melbourne, Australia. The topic for today's webinar is how to configure engine auto start with a PDM. Now we're going to cover just basically how to set up a PDM, which is our power distribution module, to provide engine auto start functions. So through this webinar, firstly we'll describe what exactly engine auto start is. Secondly, we'll take a look at the logical requirements we need to achieve this function. Then we're going to go step by step through the input and output channel setup in the PDM manager software. And finally, we're going to set up the logic configuration in the PDM manager. So this will give you a step-by-step, screen-by-screen view of what you might expect to see. Of course, each application is going to vary. So what we've given here is a typical example. This is actually based on a car that we're doing at the moment, but with most of the other car information stripped out. So we're just looking simply at the relevant components that would be used for engine auto start. So engine auto start is a concept most people would be familiar with. It's used on a lot of cars and motorcycles, and it's an automated start function which allows you to start the engine with one press of the start button or just a single turn of the key switch. This means you don't have to hold the button down or keep the switch turned until the engine fires. You simply command the PDM module to start the engine, and then it monitors the engine and cranks the engine until it starts. Normally you would also want to be able to stop this process for any reason. For example, if there's somebody with their head in the engine bay, so you normally have one press to disable the cranking. So naturally enough, the system must monitor the engine so that it knows to stop the starter motor once the engine's running. A secondary function which is very useful, for example, in rally cars or even on race cars, is the what we call a stall start or the quick restart. And this allows you, without pressing the starter button once the engine has been running, to quickly restart the engine. For example, if you stall it on the grid, or if you in a rally, for example, if you lose the car on a corner and stall the engine. And this is a very useful function with a slight extra logic overhead and the requirement for a few extra sensors in, but it's a very convenient thing to have. Okay, so what we need to make the basic function work is simply a start button or a key switch. Now this could take the form of a switch into the PDM, or it could be the form of a CAN message. Now we've taken, in this example, we're just going to use a switch input. So we've got one start button, and then we also need an engine RPM signal so that the PDM knows when the engine is actually functioning. Again, this could be in the form of a tachometer input. In this case, we're going to use a CAN channel. We're working on the assumption here that you've got, for example, an M800 ECU running the rest of the car. So again, there's some variance may be required to suit this to your particular application, but it's pretty typical to get engine RPM in as a CAN message. Now, if we want to have the stall start feature, we also, the way we've programmed it, we need to have a clutch switch or a brake switch and the throttle position. And again, we've brought some of these in as analog switches, as just a physical switch. We've brought the throttle position in as a CAN message. Now, the only output we require is the high current output to drive the starter solenoid. Now, of course, the PDM, whilst it has high current capabilities, you should be aware that it's not capable of driving the starter motor directly. You still need to drive it through the traditional starter solenoid. But that's of course typical of any engine ECU or power management product. So that's all we need for the inputs and the outputs. Now what we need to do, we have several logic requirements, and this will cover what is typically needed in a race car. So what we want is the engine to start cranking if you turn the ignition on. Now in the case of this webinar, we're not having an ignition function built into the start button. So in other words, we expect with this demonstration, you still have a separate ignition kill switch or a power switch if you like. Our start button in this case is only operating the auto start feature. So just remember that you've still got an ignition switch or a kill switch wired into your PDM, which we haven't given in this example. So we need the engine to start when we press the start button. And as a safety measure, we normally would add that you've got to have your foot on the brake switch while you press the start button so that you can't inadvertently crank the engine deliberately trying to start the engine. And we also have a condition where if the engine has been cranking, it must have stopped for at least 1 second before it will re-crank when you press the start button. Now this is to some extent related to how our ECUs work, but it just means that the engine has to show 0 RPM before the start feature will enable. And thirdly, the engine can't be running. So if your engine is running and you press this button, we don't want it to engage the starter motor. Okay, so that's the normal engine starting scenario. And the second one, which we can just highlight here, this is our stall start feature. And again, this is something where, for example, you run off the side on a rally car, stall the engine. Now, the way this works is that you can simply stomp your foot on the throttle to wide open, and you can press the brake or clutch pedal, and you don't need to actually press the start button. So you can have your hands on the wheel, and if the engine stalls, you just momentarily slam 2 of the 3 pedals, and the engine will restart. And of course, you take your foot off the throttle pedal immediately as soon as it starts cranking. This may seem slightly counterintuitive, but any of the drivers that have used this system find it extremely fast. So, of course, you take your foot off the throttle virtually straight away. But what this means is you can basically, without changing your attitude in the car or your position in the seat, hands on the wheel, restart the car instantly without having to find the starter button. Okay, now the reason, of course, we need the engine to stop cranking under a number of conditions. Firstly, of course, if the engine starts, we don't need the starter motor to be operating any further. Secondly, if for some reason the engine won't start, it's a bad idea to just crank the engine continuously. So we have a timer which will stop the crank operation if the engine has been cranking for 5 seconds without starting. Once again, you can set this to any time you like, but 5 seconds is typical. And the third condition that we want to stop cranking is if for some reason some situation arises where you don't want to start the engine while it's cranking, you just press the start button again, and that will disable the starter motor. Again, this might be the case where somebody is still inside the engine bay, the driver is perhaps a bit enthusiastic to start the engine, and you realise straight away that you don't want to start the engine, so you just press that button again. And again, I'll just remind you that we're not dealing here with ignition switch or kill switch functions. We're just talking about the starter. So your PDM configuration would normally include ignition or kill switch switching and outputs, of course, but we're not going to show those in this PDM demonstration. So that's what our logic requirements would be for these 2 functions, the basic start function, and secondly the stall start feature. Okay, so now we're going to look at a functional block diagram. As you can see, the blocks themselves don't contain any logic components, but this will just give us an indication of the complexity of this logic function that we need to start to set up in this PDM. It's quite complicated. It's by no means as complicated as what we can achieve with a PDM. This only uses a very small proportion of the available operations in a PDM. So we have on the left our inputs. Now these are in the form of either switches or CAN messages, but for simplicity, where effectively the PDM doesn't care how they come in, they're all just input stimuli, if you like. We have the brake switch, the clutch switch, a full throttle status CAN message, the start button, and our engine RPM again, which is coming in as a CAN message. Now you'll see next to my engine RPM, we have a second box here, which is effectively another logic block, and that is because it's getting raw engine RPM as a CAN message, we need a logic block which is either an on or an off signal, and that determines whether the engine is running or not running. So we take the engine RPM and we put it through a logic block before we then use it in these other main logic blocks. So just to repeat what these blocks do, firstly we have our Autostart Trigger block. Now this is the one which takes inputs from the brake, the clutch, the throttle, the start button, and engine RPM. In other words, it uses all of our inputs and via various forms of logic combines them to produce an output. This output here is a start command, and that goes into the set input of our output driver. So the output driver is a logic block which really only has one function. It has an on command and an off command. And so we've got two logic blocks to drive these two functions because they, as you've seen in our previous screen, there are many, the two requirements are quite different to each other. Okay, so the Autostart Trigger output is our on command. The Autostart End output is our off command. And in addition, we have a Autostart Trigger pulse here. Now this is simply that 5-second timer that I mentioned, and what we want there is when we start our Autostart Trigger here, that will turn on a 5-second pulse from this logic block, and that goes into our Autostart End block, which is one of the options available to stop the engine cranking after 5 seconds. Okay, and then the final output, of course, is from the output of our PDM driver. We go to our starter solenoid and, of course, to our starter motor. So these dotted line blocks are the ones we're going to construct in the PDM, and these circled input devices here are the ones we're going to set up as our PDM inputs. Okay, now we're going to take a closer look at the Autostart block diagram, and as you can see here, now we've incorporated the normal logic that you would see in a logic diagram. I have to point out here that one of the reasons the PDM is actually quite easy to use is because you don't need to design this sort of logic diagram to achieve the functions we're going to show you. You can design your logic more or less in a sentence or text base, because that's how the logic setup works, and to actually reproduce it as a logic diagram is somewhat complex. So when we go through the screen by screen description, you'll see that it's actually very clear what each of these inputs is doing, because you can read it as an English, as a normal sentence if you like. But up here we've got our brake switch and our start button. These are our two fundamental inputs which we're going to use for a start condition. Then we've got engine RPM and via this little engine running block. And we've got our full throttle status information and our clutch switch. Now, normal logic diagrams such as this one I'm showing you now is an OR gate, and that means that the two arrows that pass into it, either this signal or this signal will produce an output on this signal here. We're not going to go into the detail of how these logic diagrams work. We have actually done a webinar on the subject of PDM logic, and if you have any queries about how this might operate, it's probably worth going back and having a look at that webinar first, where we give a fairly clear description of how each of these logic functions work. So we're assuming that you understand the construction of logic functions, and I'm not going to further describe how they work. We're simply going to go through the process of building up this configuration to include these logic functions. So what we have is here, we have an OR gate, we have two inputs to it. This top input, as you can see, is our button start input, that's our normal input, and then this bottom input is our stall start input. So either of these conditions will allow the engine to start cranking. And each of these conditions, for example, a button start, is the composite of a number of other further logic functions. So we've got an AND gate here, which means that all three of these signals need to be true before this output will go true. So that means we need to be pressing our brake switch and our start button simultaneously. We need our engine RPM to be false. Okay, so I've got a little inverter gate there that turns a true signal to a false signal. And that means our engine RPM is less than 40, which is a scaled version of 400 RPM. And that means that must be false. In addition, our button must be pressed, and we must have at least 1 second since the engine was had last been cranked. So if all of these conditions are true, our button start AND gate will be true, and therefore we'll have a start trigger coming out of this output which goes into our driver. And then the stall start gate has a similar set of logic conditions. Now these are actually all just the ones we described on that first logic requirements screen, so you can see that they've been diagrammed to comprise each of the things that we needed to be able to do. Again, this logic diagram looks fairly complicated, but it's quite easy to build in PDM Manager software. Okay, so now the second half of this logic diagram, I couldn't actually fit all these on one page, unfortunately, so they've had to be split up. Now you can see our Autostart Trigger pulse block logic, and so the input from that comes from the Autostart Trigger that we saw on the previous page. This is simply a 5-second pulse, and that's 5-second pulse then goes into our Autostart End block, and that means if the engine hasn't started after 5 seconds, it will generate an end signal, which then turns off the crank. So you might want to refer back to these diagrams later when you're looking at this webinar, and you can simply spool forwards and backwards in the replay and have another look at these logic diagrams. Okay, so now I'm going to take you through a step-by-step build, if you like, on the config of this auto start function, and we're going to have basically the whole PDM manager screen on screen as we take through every single step. Now this is quite a long process, but I may only spend a short time on each screen because they really are just individual button clicks in some cases. But at least this way you get to see the whole thing being built from scratch. If you look over on the right hand side here, what we have is a block diagram of the entire PDM logic system. At the moment, this is just a blank, unused PDM, so all we have is a diagram showing PDM. As we build these inputs and outputs and these logic conditions in, you'll see this expand into quite a large tree which has all of these functions that we've built into the configuration. Finally, I should mention, of course, when you're building this stuff yourself, you should always be using this save button here to save your configuration as you build it up, so that you can also step backwards if you've made any mistakes. Okay, so the first thing we need to do in a PDM is to set up our input and output channels, and that's what we'll do now. So that's our normal PDM screen. What you can see on screen is the full PDM Manager software screen, and it's basically a blank PDM. So the first thing we're going to do is set up our input pins. So what I do is I click here on the left-hand side, and when I've highlighted my input pins screen, then I get this screen in the middle which shows me basically all of my input pins in this particular PDM device. As you can see, none of them have anything on them. That's because we haven't yet added any input channels. So to add an input channel, I put my cursor over in this area and I right-click the mouse, and then I get to add an input pin. So in this case, I've chosen, you might say this is somewhat at random, but it doesn't really matter. So I've chosen input pin, which is the A27 pin, and I've now typed in what I need to add to this pin for my start button. Now you can see in the way we've named our channel, it's called engine.start button. Now we have, there are a number of ways you can do this. Because the PDM works basically in plain English, you can name these functions anything you wish. We have a tendency to build things in blocks, and so anything that relates to our engine, we start with the word engine and a dot. And that means that anything following that dot is treed down as a separate subcomponent of the engine block. Okay, so this one's called the engine start button. It's simply a switch input. And so what you can see is the levels below. I've set it for active low, which means that when the switch closes, it will pull the voltage down from 5 volts to 0 volts. And so these are the standard input voltages that will come up when you select an active low condition based on the fact that it's a 5-volt switch input. So in fact, all you need to do here is type in engine start button and set it to active low, and the other numbers are more or less the defaults, and they're perfectly acceptable. So then we click the OK button, and what we see now is our input pin 17, which is A27, now says engine start button, active low, 4.2 volts high, 3.6 volts low. So these are the numbers we've just been entering in on that screen. And on the right hand side, you can now see we've got a block that's called engine, and we've got a sub-block called start button. So this is showing us, as we build up our configuration, what we've added. Okay, so the next thing we need to do is add our brake switch input. So we go back to we're already in our inputs pin screen. We double click or we right click on another one of these channels, and we type in lights.brake switch. Now again, this is a way of separating different functions within the PDM. It's completely at your own discretion, but we like to have all of our light, both inputs and outputs, under the lights category. So we type lights with a dot, and then that produces a new logic block, if you like, where all of the subsets of the light system are in one block. Same type of switch function, active low, so that just produces the same type of input. So we just press OK, and then on our screen we can see the engine start button, the lights, and of course over on the right hand side we've now got this extra logic block here. So those are the input channels we need. I beg your pardon, there's one further one, and that's the clutch switch. Again, any of these could be brought in as an input pin or as a CAN message. So we've done exactly the same thing with our clutch switch. Once again, I've selected a pin, typed in engine.clutch switch, and used the active low default settings below, and click OK, and that will add itself. As you can see, that's now added here, and it's also showing on the right hand side over here. So there are our 3 input channels. Of course, I would be saving this as I go. We're using that button there on the left, just so that I don't lose any information. Okay, the next thing we need to do is bring in our CAN inputs. We have 2 CAN messages. One of them is the engine RPM, and the other one is the full throttle status signal. Now, this is in this particular case, we're reading a single signal which shows us either not full throttle or full. We're not interested in the actual full throttle number. You could bring in just simply the throttle position if you wished, and build a little logic block that had a switch selection based on a throttle number. But we're just bringing it in as a status. So the first thing we do is on the left-hand side, we click on the CAN inputs function here. As you can see, at the moment, this CAN input screen is completely blank. Of course, that's because we haven't yet added anything to it. So we're going to add a CAN input. So we right-click in this area, and you see the add choice here. So I just click on that, and then it brings up an empty CAN message. So in this case, we're going to call this one engine.rpm, and that means that will be regrouped over here in our engine block as part of our other engine functions. Okay, so we type in engine.rpm into the name. Now, in this case, you will just have to follow this example. This can vary from one application to another. But in this case, we've brought it in as a normal 16-bit piece of information, for example, from an M800. So it's a 16-bit channel. CAN address is 11A hexadecimal. And one thing that is important here is we have to put a divisor in. See, it's in a somewhat small type, but you can see that's been set to 10. Now, the reason for this, this does bear some explanation, is simply that the way the PDM deals with numbers in general is it uses 8-bit control numbers, and these have a range of 0 to 255. So it's not actually possible to bring in an engine RPM number such as, say, 5,000. It's outside the range of how the PDM deals with the mathematics. So we simply divide the normal engine RPM number by 10, and that means that our engine RPM is scaled down to a smaller number that the PDM can handle. That doesn't make perfect sense, and that's also because the way the M800 transmits RPM can be done a number of ways, and it can actually be pre-scaled in terms of degrees per second or angular speed rather than RPM itself. So I won't go into detail with that. It's something that is covered in some of our other information, but we do need to have a smaller number for our engine RPM. What this does mean is that when we're looking at the RPM logic function later, you'll see that we have it greater or equal to 40, and that actually equates to an RPM of 400 because of this divisor. Okay, so now we just click on the OK button, and this one will be added to our CAN message here. You can see now we have engine RPM here, and also up on our right hand side under our engine block, we now have this RPM parameter here. Okay, so the other thing we need to add is our full throttle status. Once again, this is a CAN message that's coming in. It's been defined in another device, for example, an M800. So we're just reproducing particular parameters that we've sent from another device. This may vary in your own application, so don't pay too much attention to it. I've put it in at CAN address 11A. The offset here is 6, which means it's the 6th message, the 6 byte value in that CAN message. And we have a bit mask which only looks at bit 4 of this particular, I should say, sorry, bit 2 of this particular message. And so that's either an on or an off type of piece of information. So that means our full throttle status is either a true or a false value. That's all we need. We hit OK, and then that's going to show up in our screen as well. Okay, so now across on our engine block, as well as our RPM, we have our full throttle status. Okay, so that's what we need to bring into our ECU as our input channels. Once again, we would save our file. All right, now we're going to start setting up our logic conditions. And as you saw in our original block diagram, we have about 4 or 5 different logic conditions. Now these can be assembled either in, you could actually build this whole logic condition in one huge block. We find it easier to separate these functions into smaller blocks and then combine those blocks with a further logic block. That's one of the great flexibilities of the PDM, is that you can build your logic in a number of different ways depending on what your habits are or what you find most convenient or what you find easiest to view later and understand. So here we've clicked on our left-hand side, we've clicked on our conditions parameter. We've got no logic conditions set at the moment, so we have a blank screen. So we're going to build each of these logic conditions one at a time. First one is the engine run status, and this is the one that we're going to use from our RPM signal, which comes in as a CAN message. Okay, so I right-click on the in this blank area here, and I click on the Add button, and then we bring up a blank condition. So we've called this one engine.running status. You can see all we've done so far is type that into the box. Once again, because we've got an engine and a dot here, will become part of this engine functional block over here when we finish entering this parameter in. So what I'm looking at here is just simply the engine running status before I've added what the actual conditions are. So then I click on the Add button, and what I need is a simple condition which shows me if the engine RPM is greater than 400 or equal to 400 RPM. So our operator, we click on this pull down here and we select greater than or equal to. We use our channel engine RPM here, which is one we've already defined. We say it's got to be greater than or equal to 40, which equates to 400 RPM thanks to our divisor. And then we've put in a very small delay here of 0.3 seconds. That's not particularly critical. Then we click on the OK button. And what you now see here is you see engine running status equals engine RPM greater than or equal to 40, true for 0.3 of a second, or false for 0.3 of a second. So that's our first logic block. Okay, then I click on the OK button here, and there it is in our logic conditions screen. So that you can confirm that that's what you want to see there. And then when we look over here, we also have engine running status as part of our engine block in the overall logic diagram. All right, so we have a few more logic blocks to add. Again, I'm going to go through this fairly quickly. You can replay this webinar and look at each of these individual blocks, but clearly the point is here we have to add each of these one at a time. So the next thing we're going to do is build that rather complicated block, which is called Autostart Trigger. I'm actually going to do this in two separate parts, which I'll explain a little bit later. So we've opened up a new logic condition called Autostart Trigger, and you can see down below that there's actually no conditions for it yet. Okay, so now I add a condition, which I do by clicking on the bottom condition and then clicking on the Add button. So the first thing I need to do is I need to have our engine start button and our brake switch light being turned on at the same time, or being true at the same time. So the first thing I do is I select my operator, which is an AND operator. Then I click on this box here and I select my two channels, the engine start button and the lights brake switch. And then the timing, you can also put delays into this, but we've just set these to 0, which is the default. So that means as soon as these two channels are true, my AND condition will be true. Then I click on the OK button, and you can see that is showing now in my Autostart Trigger conditions. Now, what we need to do here is we need to add numerous of these conditions, because as you saw in our logic diagram, the Autostart Trigger actually has a number of components, and we can just keep adding these on down below. So you can see here we have an AND in grey and we have an OR in grey, and I can add onto this. As you can see, I've just clicked on the AND now, and you can see that's blue, and then over here I click on the Add button. That means I'm going to build an AND block which combines a number of logic functions together. So I click the Add button, and now the second thing I'm going to add is that my engine running status must be false. In other words, if the engine is already running, I don't want the starter motor to be engaged. So I select here, I select the false as my operator, then I click here and I select engine running status, and then I click OK. And when this happens, you'll see on the next screen, we now have two Autostart Trigger logic conditions that are combined. So this is how we build complicated logic functions from individually simple logic functions. So I need to add some more here. I'll just click again. I beg your pardon. So now what I'm showing here is the basic engine auto start trigger, and you can see that also appear over here in our logic block. So there are a few things we need to add later to this, but we actually need to go through some other logic building before we can come back and make the final additions to this. Okay, so now we've got our auto start trigger, and you may recall we had a 5-second pulse which was triggered from that trigger, and that was the 5 seconds of engine cranking, which would then disable cranking any further if the engine hasn't yet started. Okay, so now we're going to add another condition, which is called auto start trigger pulse. This, of course, is the blank one because I haven't yet added anything in. So I click here, and then I click on the add button, and all I'm looking to do here is generate a pulse. So we've got a specific operator for that, which is called pulse. I just pull down here on the pull down. I select pulse. I want to make this pulse on the rising edge, which means when the auto start trigger starts operating, I want a 5-second pulse from that. I click here and I can see that's my channel, auto start trigger, and then I've selected 5 seconds here. So that's how easy it is to generate a 5-second pulse from another existing condition. Click on the OK button. Now you can see here we've got it in our box below. That's actually all we need for this auto start trigger pulse. We're not building a complex logic function here, just a simple pulse. So I click OK, and then we can see now we have our auto start trigger pulse in our box on the left, in the center, sorry, and we also have it in our logic diagram. Now the other thing we need to do is build our end control mechanism. So we add yet another condition here. It's called Autostart End. Then I click down here and I click on the add button, and we'll build up this condition again from a series of operations. The first thing we need to do is, if the engine is running, we don't want the cranking to continue. So we select a true operator here, which is the default effectively. Then on my channel, I click on the engine running status. Now this is one of the conditions we've already set up previously. Now from this you can see that we actually need to create our logic blocks in a certain order, because some of these logic blocks actually depend on other logic blocks for their function. So this can make things a little bit complicated, but nonetheless we've already created our engine running status. That means anytime this is true, it's going to turn off the starter motor. So then I just click on my OK button, and you can see here we have it. Auto start end equals engine running status equals true. Now there are other parts to our end message, our end condition. So we then click on our OR selector here, and we click on the add button here, and then we add our next part of this auto start end function. And what that is, again, is we're going to use that auto start trigger pulse that we've just created. So we select the operator as a pulse. We look for the falling edge of the input channel, which is our auto start trigger pulse, and that's the falling edge means that that's the edge after the pulse turns off after 5 seconds. And I've actually included a 1-second delay here as well. Now this is just so that we can segment our timing slightly. We don't want any overlap in our timing, and so there are a couple of occasions where we put extra small delays in. Not a particular concern, but it just means that we can't have two logic operators effectively fighting against each other simultaneously. Again, we click on our OK button, and now you can see in our auto start end, we will end our auto start. In other words, we'll stop cranking if the engine's running, or secondarily, if our trigger pulse has timed out after 5 seconds without the engine starting. Now we do have one further one to add. So again, we click on the OR. I beg your pardon. That's all we're going to do for the moment. Now on the right hand side, you can see this tree has slowly been expanding and building up. We've now got our auto start end function as well. Okay, now before we can add the further complexity to those functions, that's why I thought I was going to add something else, but in fact what we need to do is we need to build our output pin drive, which is the one that drives our starter solenoid, because one of the things we would have seen in our earlier logic diagram was that there are some situations where if the starter solenoid is actually operating, we need to stop it again, and that's, for example, if you press the start button while the engine is already cranking. So this is one of these things where you need to build your logic in the right sequence, because we can't define our output pin until we've got our trigger functions, and then we have to go back to our trigger functions and modify them slightly because some of them are actually dependent on the output function. Sounds a bit confusing. So now I've clicked on here on output pins, and you can see again we've got a blank section here because nothing has yet been defined. So now we're going to either right click or double click on one of these output pins. Okay, I've just selected pin 1. This is actually fairly arbitrary, but now this one is our starter solenoid output. So I've called it engine.starter solenoid, as you can see here. Once again, the dot in this position means that it'll appear over here in this block under the engine block. So the engine starter solenoid is a simple output. We've set it for 15 amps maximum current. There's a retry delay of 5 seconds, which means that it can have multiple goes. And in fact, we've set it to 0 retries because we're effectively controlling how this works through our logic build-up. Now the control, as you see in the bottom of this box, there's a control box, and this allows you to control how that output is operated. And we're going to operate it from one of the conditions, in fact a series of conditions, because that's what we've been building up in our logic diagram. Of course, the other option here would be channel. And for example, you may just simply want to drive that straight off the start button, and that would be a traditional start feature rather than an auto start feature. In that case, you'd select channel, and then you'd click over here and just simply enter in your start switch channel, and that's all it would take to turn the output on and off. Because we're building a complicated function, that's why we're using the condition. So here you can just see the name of our thing. We then click on the add button, and this is where we build in the logic that we need to make this operate. Okay, now this is another type of logic operator that's very useful in a PDM. It's called a set reset function. This is, again, if you like, it's a electronic equivalent of a standard logic function in normal electronics, but we've done this via software rather than via a hardware type of device. That's the whole point of a PDM. It's fully programmable. So a set reset is a switch which has an input for turning it on and another input for turning it off. The set input turns it on, the reset input turns it off. So firstly, we need to click on our operator pull down here, and that will allow us to select the set reset function, which is quite low. There's a very large list of pull downs there. Now, the set condition, which again is what turns our starter motor on, the result goes true, and we just pull here in our selection of input channels, we pull our Autostart Trigger, which is the logic block that we've built up earlier. So that will turn our starter motor on, and then to stop it, we click here and we select Autostart End. So those are the two logic blocks that we've already built up that are going to control our output channel. So then we click on OK, and then you can see down here the condition now shows most of this message. It's actually a little bit hard to read there. When we click on this OK button here, it'll then appear on our output up here. So we can see engine starter solenoid, and the control shows the set reset condition and what the two input channels are that control the set and the reset. And once again, on our right hand side, we now have an extra function here, which I'll just find. Starter solenoid here. So that's been added to our tree of logic. Okay, now having set the starter solenoid, as I mentioned, we actually have some of our trigger conditions that are dependent on the start solenoid. So we then need to go back and add some further detail to those triggers. So the first one is the Autostart Trigger. What you can see here is I've reopened that. I've gone back to my conditions screen, which is over here, and then I've double clicked on Autostart Trigger, and it's brought up my properties. So what I need to do here, I've clicked on the AND because I'm going to add in an extra condition which is based on whether the starter motor is currently operating. So I click there, then I click Add. Once again, I get to add a new logic condition. This is a false operator, so I pull down here, select false, and then I click here and I select my channel, which is the engine.starter solenoid, which is the channel we've just created. So in other words, we're not going to allow the engine to crank if the starter solenoid is already turned on. It must be false. Put in some small delays here as well. Again, this is just so that we don't have any overlapping timing. Click on the OK button, and then we see that's been added to our start trigger set of conditions here. Now, this first set of auto start trigger conditions are the ones that relate simply to our basic start. They're not the stall start function. So I've added my output pin check, and that means that It's not going to crank the engine if it's already cranking. That makes perfect sense. But now I need to add, as well as that, I'm going to add my stall start condition. So now I click on the OR little parameter there. You can see that in blue. Once again, I click on Add, and this is giving me a complete second set of conditions, which will be our stall start setup. Again, I'm going to go through this fairly quickly, but you can retrace any of this at any time just by replaying the webinar back, and you can see each of these screens. So we add a new operator, which is a pulse operator. It's a falling edge pulse, and it's based on the engine running status, and it's got a 10-second timer. So what we're looking at is if the engine RPM falls below the 400 point, we get a falling edge on that engine running status. Okay, and then what we need is if it's within 10 seconds of the engine stalling, this pulse will become available. And that just means that if the engine stalls after 10 seconds, the stall start feature won't work and you'll have to press the starter button. Again, this is just a safety feature. So we click on the OK button, and then you can see we've got our first group of this is our basic start function. Then we've got an OR here, and this is the beginning of our stall start function, and we're going to add further features in here. So now I add another one here, and this is a pulse from our full throttle status. So again, this is designed to only allow the stall start feature if you stab the throttle and you have the clutch switched as well. So first we add in our throttle pulse. I won't go through the detail here. We've got a rising edge. We've selected our engine.full throttle status message. We click OK, and then that appears here as a secondary feature of this condition. Then we need to add one more feature. So again, we click, and what we're looking for here is actually two possibilities: either the clutch switch or the brake switch being depressed at the same time as we have full throttle, at the same time as the engine has been stopped for less than 10 seconds. Quite complicated. So our operator here is the OR function, and then our two input channels are the engine clutch switch, or which we've just selected, or the brake switch. So these just become active instantly. We click OK, and we'll see them now added below here in the engine clutch switch or the lights brake switch. So we've now got our restart, our stall start feature added as a secondary option in our Autostart trigger. Then we just click on OK, and now you can see this Autostart trigger is quite long. The whole conditions part of it is actually too long to fit on the screen, but we've just seen how that works. Okay. Now the other thing we were going to do is we needed to add our solenoid output check on the end function as well. So I've just re-clicked over Autostart End here, double click that, it reopens up my box here, and what I'm looking here for is to add another function here, which you can see I've highlighted there. So you click there, you click on the add button, and then we're adding one more thing, which is again, this is designed to stop the engine cranking if you press the start button while it's cranking. And so to do that, we needed to be able to see whether the output was already active. So firstly, we're going to create a pulse operator here based on a rising edge from our engine start button. And that's just for a very short amount of time. It means if you stab the starter button, it's going to stop the engine cranking. Click on OK. And so this is our third condition that we're adding in to stop the engine cranking. So we now click on the AND there. We add another control condition here, and this is again where we're looking for if the engine's already cranking, i.e. the solenoid is turned on, true, we need to stop the engine if you stab the starter button. So we just add this in as an engine starter solenoid, click on the OK button, and you can see that now has been added here. So there are now, if you look at our end logic function, there are three possibilities for how the engine cranking will stop. The first one is when the engine is actually running. The second one is if the Autostart trigger times out after 5 seconds without the engine starting. And the third one is if the engine's cranking and we stab the starter button, that will stop the engine cranking as well. So that's built us our very complicated end function as well. So again, we click on OK, and that gets added to our Autostart control message here, which has become quite long as well. So we've built everything we need into this. Again, you should always be saving this file as you go by clicking on the left-hand button. And you can see over here our logic tree includes all of the things that we've built in, including the logic functions and things like clutch switches and so forth. Okay, let's just finally have a quick look back at our block diagram. It's worth just reminding ourselves of what it's doing. So the input triggers here all come from all 5 of these input channels. The trigger pulse is our 5-second pulse, which will stop the engine cranking if it hasn't started within 5 seconds. And our end function here works on either the engine running, which is this signal here, engine output. Sorry, I beg your pardon. If the engine is running, here we will stop our engine cranking. If our output is turned on and we hit the start button, which is this input here, that will also stop us cranking. So you can see these are all combined without us showing the actual logic functions. The main thing here is our engine starter output has 2 separate triggers, an on trigger and an off trigger, and then the output goes to the starter solenoid. Okay, so this is a fairly complicated set of conditions, but you can see that the whole point of how to make these work is to build them up one step at a time. You can add or edit or change any of these functions as you go, and of course you can also rename your configuration. If you have a simple version, you can give it one name and then you can add further to that and give it a different name, so you've got a fallback position in case any of your logic doesn't work as you might have expected. Again, we can add other functions. This, because we've only shown you just how to do auto start. Typically, a PDM obviously has a lot of other input channels to do with lights, indicators, engine kill switches, and so forth. But we've just left it all blank so that we can just concentrate on the elements that we need to build this auto start function. Okay, now if you're unaware of our webinars, well, obviously this is one of them, but of course there are many other webinars available which we've pre-recorded. You can go to the website that's shown there, and you can look at everything we've presented in the past. Again, I'd suggest we have a number of PDM webinars that you may wish to look at, and we have a fairly detailed one on how PDM logic is constructed. This is a similar version, a similar thing to what we've done here, but we've been more specific here with a particular application. We also have a web forum where many of our customers and users constantly interact with each other and also with our support staff here in Melbourne. And you can go to that also. The address is shown there, and there's a specific topic or subgroup there for the PDM. So you can interact with other people that are using PDMs, and you can exchange information. And you can also, we also monitor all of this stuff, and if necessary, we can give help as well. So I hope this has been of some help to you. We will be conducting further PDM webinars in future. You can also contact us via email, but really I'd suggest the first thing you do is go and look at the forums, and from there you can usually get any sort of help that you might require. Thank you very much for attending, and that's the end of this webinar.